Hi there, my name is Aarav Jaichand and I worked on my Polygence project with my mentor Tim. I did my project on how machine learning can classify news articles and its most effective methods. I chose to work on this project because I wanted to dive deeper into text classification and learn more about it. And when brainstorming project ideas for text classification, we decided to go along with classifying news articles. Our task, more specifically, was to classify a news article based on its headline and short description. We had to categorize it into 42 different categories, including politics, world news, entertainment, and so on. On the screen is an example of how the program would work. An input, the news article headline, and the target is what it's supposed to be, and in this case it's science. The data set we used had 42 different categories and 210,000 different articles, and these categories are shown on the screen in a word cloud, so the larger the font size, the more appearances it makes in the data set. We used multiple models for this task, including one from the scikit-learn library. The others were pre-trained deep learning models from a website called Hugging Face. The best performing model we used is called Mini-LM, which uses sentence transformers, and this deep learning model was able to complete this task with an accuracy of 75.42%. Since we loaded this model directly, we had to choose one of the 7 hidden layers in this model to aggregate. After compiling the results from each of the 7 layers, we selected the results from the layer that did the best. We used the MLP classifier from scikit-learn second, and this model only takes the numerical data to classify. Since we're attempting to classify text, not numerical data, we needed to extract numbers from our article headlines and short descriptions. We did this by calculating some ratios, including the number of uppercase to lowercase letters, sentence length, and average word length. We figured that a politics article might have more names than an article about travel, resulting in more uppercase letters. When feeding this data into the model we fine-tuned ourselves, we got an accuracy of 64.35%. This was better than the third model we used, the Berta version 3. This model was loaded similarly to Mini-LM and functioned in a similar way. Mini-LM, the best performing model, was also the smallest model we used, only containing 22.7 million parameters, compared to Berta's size of 184 million parameters. In conclusion, the Mini-LM model is the most efficient and had the best accuracy, as we can see in the chart on the screen. So, how can this model be used? News apps and organizations like Apple News, Google News, CNN, Wall Street Journal, and so on have hundreds of thousands of articles coming from many different categories. Organizations like these can use this to organize their apps or websites more efficiently by feeding them into this program. This is just one of the many possible ways text classification can be seen or used in our everyday lives. In addition, these deep learning models can be used for other purposes, like video categorization on YouTube or other video platforms. The task of classifying news articles into different categories, or just text classification in general, is difficult when your classifier can only recognize numerical data. We realized that the numerical data we extracted from the text wouldn't be helpful enough to make clear distinctions between categories. Here's how the MLP classifier works. The input layer has the numerical data we extracted from the text, goes for the hidden layers, and goes out the output layer, and the output layer consists of the category, like politics, entertainment. That's what the output is. We then switch to deep learning models like DBERTA and MiniLM. These models can do many other things. For example, spam identification, language translation, sentiment analysis, and many other things displayed in the image on the screen. In conclusion, for the task of news categorization, deep learning models are the most efficient in terms of speed and accuracy. Thank you for listening.